Hello everyone, this is the another video of this challenge, and right now I'm learning the sorting algorithms. Till now I have completed the selection sort, insertion sort and bubble sort, which I have also explained in my previous videos. You can check them inside the I button or in the description. Now in this video I'm going to explain the merge sort algorithm, which is the very important sorting algorithm. And before going into it, firstly I will tell you the flow of in what flow we are going to proceed in this video. So firstly, I will explain that why we need the merge sort, because obviously if we are learning something, then what is the reason behind it? If we are already having the other techniques, like the for before the merge sort we have already discussed, the insertion sort is there, bubble sort is there, selection sort is there, then why we need the merge sort algorithm? So that I will discuss. Then I will discuss the core idea, that what is the merge sort algorithm and what principle it works. And then I will just take a simple example just to give a brief idea about how the merge sort algorithm behaves, just a overview of it, that how it behaves. And then I will take another example just in order to explain the complete flow from in very detail, that how the flow of merge sort, how the what is the flow of merge sort, like how it works on a particular array in order to sort it. Okay, that I will explain with the help of an example. And then we will go to the implementation part, and then write the code, and then just analyze the time complexity of it in detail, that how the time complexity comes. Okay, so let's get started with this video. So firstly, why the merge sort algorithm came? Like, if we are already having the selection sort, bubble sort, insertion sort, then why we need the merge sort algorithm? So it's because we have already seen in the previous sorting algorithms that they are becoming very slow at big O of n square time complexity. So in order to get a more optimized solution, so that that solution perform better and becomes more optimal, that then we need the merge sort algorithm, because merge sort algorithm makes it more optimized, which takes the time complexity of big O of n log n. So I told the time complexity as of now itself, but I will explain later later on when we will be going in the implementation part, that how the time complexity came. Because it is a more optimized approach, and also performs and also makes the solution better, so that it can sort the array in more efficient manner. So that's why the merge sort algorithm came. Now let's get into that, what is the merge sort algorithm, what is the core idea behind it. So merge sort algorithm is a divide and conquer algorithm, in which it involves some of the steps, some of the steps strategy it follows in order to sort the array. And the core idea behind it is that whatever the array we are given with, just imagine an array which is a large array, and then in that, if you are using the previous sorting algorithms, like selection sort, insertion sort, then in that case um, they become slow in order to sort the array, like takes big O of n square time complexity. So now comes the merge sort algorithm, and merge sort algorithm says that, okay, I am having the larger array, I will just convert it into like in the halves, like I will divide this array into the two halves, and then I will sort those two halves recursively. Now what does this mean, that sorting the two halves recursively, that we will come to that. But the three steps are simple, that it firstly divides the larger array into the two halves, and then it sorts those two halves recursively. And whenever those two halves get sorted, it just merges both in a final sorted array. That's what the merge sort algorithm behaves. Okay, so this is how the merge sort algorithm behaves. In this, it firstly divides the array, as it is written here, into the halves, and it divides that until each piece has one element, and then merges the pieces back in the sorted order. This we will see more with the help of example. Just the simple idea is that it divides the entire array into the two halves, then it sorts those two halves recursively, and then when these get sorted, it just merges them into a final sorted array. So that's what the merge sort algorithm says. And it is a divide and conquer algorithm, just a simple strategy, that it firstly divides, then it sorts the two halves, and then it merges both of the halves into a final sorted array. Now let's get into a simple example just to get a basic idea of how this sorting algorithm works. So this is a simple example I have taken of array size of 4. Elements are 8, 3, 5, 2. Now we have to sort this array. Now what merge sort says, okay, I am having this array. Now I will not sort it directly. I will convert it into the two halves. So it will divide it into two halves. So here 8 and 3, it is divided for one half, and this 5 and 2 divided into two half, second half. Now this is the first half, this is the second half. Again merge sort says that, okay, I am going to the first half, and now I will be again dividing this into two parts. So it will divide into two parts, and now the array becomes like this. And the moment the array becomes of size 1, or the array is having element 1, then and there the merge sort algorithm stops. and it says okay, now I got the element which is I got the array which is having only one element, and therefore it is having one element, so it need not to be split again because it is already sorted in itself. So I got the first half as a sorted half, and now I will go to the second half. Again it sees that okay, this is again a sorted half, so now it got both the sorted halves, and that's what it says, that when I will get the both the sorted halves, I will just merge them into a single sorted array. So when it will merge these, the single sorted array will look like 3 and 8 like this. And when so it is like done when a kind of temporary array is made so that it can store in that, and after that this array gets copied inside the original array. So this array becomes like 3 and 8. And when this is completed, it says okay, I have completed the first half, I have sorted the first half. Now I will move towards the second half. In the second half, again the same process is followed. It firstly divides this array into two halves. So the first half is this, second half is this again, and now it sees that okay, there are only one element, this is only one element, and at the end I will just stop here because I got the two sorted halves. So now I will just take these two sorted halves and merge them, so it will look like 2 and 5. So here 2 and 5 will come, and it says now whatever the two halves in which I have divided this bigger array, now it is converted into the two sorted halves. Now I will take these two sorted halves and merge them. So when it will merge, it will become like this 2 3 5 8. So this will be the temporary array which will be again copied into back to the original array. So this is the simple idea, or we can say the merge sort behaves in this manner. Now let's take this, and by this we have just got an idea that how this works. Now we will go to the complete flow of the merge sort algorithm, how it works. Okay, and now let's get to the another example in order to understand it in a complete flow, that how the merge sort algorithm works on a array in order to sort it. So this is a simple rule, the three-step strategy that the merge sort algorithm follows. Firstly, it divides the array, then it sorts the both the halves, and that is done recursively, and then both the halves are merged when they are sorted. Now let's understand through this. This is the array I have taken of 7 size array, and in this the number of elements are 7. Okay, in the previous example we have seen that there were 4 like even number of elements. So in that we have divided like in 2 and 2, but here the 7 elements are there. So how we will divide? Either we can divide in 3 elements and then 4 elements, or we can divide in 4 elements and then 3 elements. So the result will be same, there is no any change in that. So I am explaining it with the approach. I am taking the 4 elements and these 3 elements. Okay, now merge sort says okay, I have divided this into two halves, this 4 elements and these 3 elements. Now these are the two halves. Now I have to sort these, but these will be sorted recursively. Sorting the two halves recursively means divide the array till the point where you get the array which is having only one element. Okay, again divide the array repeatedly until you get the array with one element, means the array size is 1. Because at that point, when the array is having only one element, means the array is sorted in itself because it is containing only one element. There is no need to split it again. That's what it means, that sorting the two halves recursively. Recursively means again and again call that same function in order to divide this. Okay, so this is the first half in which the merge sort algorithm says okay, now I have divided this into two halves. Now I will go to the first half, and I have seen this array. So this is the smaller array as compared to this. So that's what happens in the recursion. We have already seen that every problem is divided into the smaller problem which can be solved, and when it moves here, it will see the first this array. So now it will again divide this into two halves. So this will be divided into these two elements and these two elements. These both halves are again came here. Now merge sort says that okay, again let me go to the first half and check for this. Again this is the array which is smaller to this, but yet it is not a array which is having one element. So again it will divide with the same approach. It will again divide, again it's split into two halves. So again it will be divided into 12 and 8. And now merge sort says that okay, let me go to the first half. Now it will see the first only the one element in the array. So it will say okay, now the array contains only one element, and because it is sorted in itself, so I need not to split it again. So now it will return just it will return from here because I got the first element. Oh, sorry, one element which is already sorted. Now I will move to the second half, and it again sees okay, there is again one element. So I will again not move ahead because it is already sorted. So it will again return from here, and it says that now I have got the two elements, sorry, two arrays, which, or I can say the two sorted halves, which I can now merge. So this is one sorted half and this is another sorted half, and now it will merge both of them and it will look something like this. 8 will come here and 12 will come here. Now this is the kind of whatever these elements are sorted into, the sorted halves are there. When they are merged in a temporary array. They are merged in the sorted order in the temporary array, and after this temporary array gets copied to the original array. So here 8 will come and here 12 will come. Let me just write it here and here also. So here 8 will come and here will come 12. Now this is the merged sorted array which is merged in the sorted order. Okay, now this we have got. Now this merge sort algorithm says, okay, now I have got this first half as sorted. Now I will move towards the second half. So when it moves towards the second half, it will see again, oh, okay, I am having a larger array. Now I will have to divide this into two halves. So it will again divide. So it will become 9 and it will become 3. Now it will go to the first half. It will see, okay, 9 is there. This is a single element. It is sorted in itself. So therefore I will be going back because I have sorted this first half, or I have got a sorted first half. Now I will move towards the second half. In the second half, it again sees that there is a single element which is already sorted in itself. So therefore I will be moving back. And now I have both the sorted halves. So I will again take these both the sorted halves and will merge in a temporary array in a sorted order. So this will be again a temporary array. And now when this is sorted, it will again move to this original array. So now it will again, it will become 3 and it will become 9. And now merge sort algorithm again says, okay, now I have got these two sorted halves, and now I will merge again these because these are the two sorted halves. So in order to merge, it again takes a temporary array and it will be created like this: 3, 8, 9, 12. So it will be then just copied here again. So it will become 3, 8, 9, 12, 3, 8, 9, and this becomes 12. Okay, this is the array which will temporary array which will get copied. And now this merge sort algorithm says, okay, now I have sorted this first half. Now I will have to move towards the second half. It will come to this, and now again it will say, okay, I am having again a larger array. I will have to firstly divide this. See, there are again 3 elements. These are the odd number of elements. So the same procedure which we followed here, do not take like that, means it can be done, but whatever the process we followed here, that the greater elements and then the smaller elements, means the 4 and 3, same which we will follow here also, like 2 elements and then 1 element. Okay, so this is again divided into two halves. Again the merge sort algorithm will come into the second half and it will again see, okay, this is a larger array, let me divide this first. So it will divide and the array will look like this. Firstly the 11 will come and 5 will come here. Again it will go to the first half, sorry. So it will see again as one element array. So it will say, okay, this is again sorted in itself, so let me move back and go to the another part. Again it is sorted, so again it will move back and it will see, okay, now again I am having the two sorted halves. So I will again merge these inside a temporary array in the sorted order. So again this will become 5 and this will become 11. So this will become 5 and this will become 11. And now the merge sort algorithm says, okay, now I have got this first half as the sorted form, in the sorted form. Now I will move towards the second half. It will move towards the second half. That this I have just mentioned here just for the simple visual, but it will just see here, yes, this is the sorted order, only contain the one element, so therefore I need not to split it again. So therefore I will move back, and now I have got both the sorted forms, both the sorted halves, so I will just merge them. And when it will merge, it will become 4, 5, 11. This will be the form 4, 5, 11, and this will be again copied here. So it will become 4, 5, and 11. So this is how it becomes. And again, now merge sort algorithm says, okay, now in which I have divided, this is the first half and this was the second half. Now I have divided and also sorted them recursively. Okay, and now it has been, both of these halves have been sorted, so therefore I can merge these both the sorted halves, and the final array will look like this. Now this we can call it as a temporary array, and then this will be again copied back to the original array here. So this will be the final output that we want as a desired result as the sorted array. So this is going to be the flow of this. Now one more important thing is that when we are merging this, just let me take you back here. When we are having these two sorted halves, and one sorted half is this, second sorted half is this, and we have to now merge this. So now how the merging takes place, let me just give you a brief about that, and that we will also see in the implementation part, that how we can implement it and write the code for it, and also in the dry run. So how we merge these, Like this is my first sorted half, this is my second sorted half. So let me just explain this, how the merging takes place. Okay, in the sorted order. So here I have taken these two arrays. These are the sorted ones. This 3, 8, 9, 12. This is the first sorted half. Okay, let me write. Let me just write here. This is the first sorted half. First sorted half, and this is the second sorted half. This is the second sorted half. Okay. Now let's just get here. Now we have to merge them in the temporary array in the sorted order. So what we will do, now we know that this is the first sorted half, sorted in itself. This is the second sorted half, sorted in itself. Therefore their first elements will always be smaller. So we will take two pointers. Let's say the L is at the first half, first sorted half at the first index, and R is the another pointer which is pointing towards the second sorted half's first position. Now we will start comparing which is the element at L or R, which is the element is smaller. And the moment we the point which where we get that yes, this is the element which is smaller, so we will just move that pointer ahead. Okay, so let's just start. Let's get started. This L and R, where they are pointing, which is the element which is smaller? So 3 is smaller. So just take that 3 and add inside the temporary array. So 3 will come here. Okay, let me just change the color of this. Okay, 3 will come here. And now L will move forward. Again, check this, which element is smaller, this 8 or this 4. 4 is smaller, so 4 will come inside this, and then R will move ahead. Now which element is smaller, 8 or 5? 8 is, this 5 is smaller, so 5 will come here, and R will move ahead. Now which element is smaller, 8 or 11? 8 is smaller, so 8 will come here, and then L will move ahead. Now which element is smaller, 9 is smaller or 11 is smaller? 9 is smaller, so 9 will come here. Then L will move ahead. Now which element is smaller, 12 is smaller or 11 is smaller? 11 is smaller, so 11 will come here, and R moves ahead. And the moment any of the pointer in both the in the first sorted half and in the second sorted half, any of the pointer moves out of bound in the another, whatever the another sorted half is there, whatever the elements are present there, just start from that position, and whatever the number of elements are present, one by one add them inside the temporary array, because all the elements in the this particular half is completed, so we need not to compare anything. So whatever the elements are present here, just take them, they take them one by one and put it inside the temporary array. So 12 will come here, and this is how we will get a sorted final sorted array, and that is inside the temporary array. Now at the end, we can just take this temporary array, all the elements, and just copy them inside our original array, so that we can get the desired result here. Now copying the elements from the temporary to the nums array, that is not a big deal, that we will see in the code itself, that how we can copy those elements. So this is how the merging takes place. When we are having the first sorted half, second sorted half, we just take those, and based on this particular logic which I have just explained, the merging happens of both the sorted halves in the sorted order, and therefore this temporary array takes these elements, and then these are just copied back to the array, in the original array where we want. Okay, so that's I have just explained for this two sorted halves. This works in all these, like these two sorted halves, then these two sorted halves, and I have just explained for this two sorted halves. So this is how the merging works, which is the core and the important part in the merging, in the merge sort algorithm. So this is how it works. Okay, so now we have completed the step-by-step explanation of this particular example in very detail, that how the recursive calls move. That firstly, this merge sort algorithm divides this larger array into the two subarrays, to smaller subarrays, and it performs this recursive calls again and again until the arrays are having only one element, and then it starts to move back. It starts to move back means whenever we got the arrays with the one element, with the one element, is the array size of 1, it then starts to merge those sorted halves, because the one element in the array is sorted in itself. So these are the sorted halves. Now then it starts to merge those sorted halves, and the merging takes place from bottom to up. That's how the merging takes place, and this is how it just performs in the 3-step strategy. So first step is simple. Let me just write here. Okay, so the first step is, let me just change the color of it. So first step is that divide the array, the larger array, into two halves. And second step is, when we have divided this array into two halves, then sort the two halves recursively. That I have also explained, that how the sorting happens recursively. Like first we just divide it again and again into the halves until we get the array of one element, or the array size of one, and at that point we just stop. And the third step is then merge the sorted halves. Okay, so this is the three-step strategy which the merge sort algorithm follows. And because it is using the recursion, so obviously it is the important point that when will this recursion stop, so that we have already discussed. But just for the explanation, that the base case, what will the base case become? Base case will become when this array will be having only one element, means the array size becomes one. At that point, the base case will be made, and that we will see in the implementation, that what we will write in the base case and how the recursion will stop. So the just recursion will stop when the array will having the only the one element. At that point the recursion will stop, and till that point the recursive calls will be made again and again in order to divide the array, so that it moves towards the base case, and when the base case hits, it just stops and then returns back. So that's how the merge sort algorithm works, where we have seen the flow of the merge sort algorithm. Okay, so now we have understand the flow of this merge sort algorithm, and now I will just give you a brief implementation, that how we can implement this, whatever we have just discussed here. So firstly, what happens is that the merge sort algorithm, for the merge sort performing, for the merge sort function call is made from the main function, or okay, so merge sort function is made, and in that merge sort function we just give that array whatever we have to sort, and it is written in that way, like the nums array itself. And then we take the low and we take the high. We take the low and we take the high. Now what is this low and high? And when we are calling the merge sort function in order to perform the merge sort, in order to sort the array, we just give the low and high. Low means the 0th index and high means the last index along with the array. Okay, and now this is given because when we are sorting this array, when we have to divide this into two halves. Now we do not do like that. We are taking the to the two different arrays or the temporary arrays in order to place these two halves. We just use the indexes, and in order to divide them into two halves, so based on the indexes we just finds the mid index, and based on that, with the help of high and low, obviously we will when we are sorting into two halves, we will be we should know that what is the mid index, then only we can divide it. So in order to get the mid index, we should know that which is the first and last index. So for that purpose, the low and high are given here, and based on that, we find the mid index. So to get the mid index, we use this low plus high by 2. Low plus high by 2. This gives us the mid index, and after that we perform the. After then we made the recursive calls. Okay, so now firstly we have found the mid index, and now after getting the mid index, we will call the make the recursive calls for the another two halves. So for the first half, what will be the indexes from 0 to mid? What is the mid we have we got here? 0 plus 6 divided by 2, that is 2 that is 6 by 2, that is 3. So 3 is the mid index. Now 0 to 3 will be the first half, and this 4 to 6 will be the second half. So it means low to mid is the first half, and mid plus 1 to the high, that is the second half. So for that we will have to again make the recursive calls, and with this merge sort function we will give the nums array, and whatever is the low index and the mid one, that will be going. And for the another half, we will call the we will make another recursive call in which we will give this nums array, and then mid plus 1 and high. So with this we will get we will get this recursive two sorted halves. And after these two and after performing these recursive calls, this merge sort for calling the merge sort function for the first half and merge sort function for the second half, in order to sort them recursively again and again, making these recursive calls. And when we will get the sorted halves, then we will merge them. So we will then just write the merge function, inside the merge function, what are the indexes we will need? We should know what is the low, what is the mid, what is the mid plus one, what is high. So in this we will have to give low, we will have to give mid, and we will have to give high here. So this will be the implementation. Now this is the basic implementation which we will be writing inside the merge sort function, and then we will write the merge function, that how the merge happens, how the merge works. Okay, so now we have written this particular implementation, but obviously whenever we are making the recursive calls, then we should have the particular base case where these recursive calls must be stopped. These recursion should stop. So for that we should have the base case, and this base case will be what? Firstly, this base case will be that we have already seen that whenever the array is having only one element, whenever the array size becomes 1, then the recursion stops. So when the array size will become 1, at that point what will be the value of low and high? See here, low is 0, high is 6. In this case, low is this index, high is this index. In this case, low is this index, high is this index. But in the array which is having only one element, low and high both are the same. So therefore the base case will be that when low becomes equal to high, at that point we have to stop and just return from there. At that point it will be stopped. Now there is one another case that we also write here, that low is greater than high, that we will also see, that I will explain separately. So for now, just understand that whenever the low becomes equal to high, at that point we have to stop, and these recursive calls will be stopped, the recursion will be stopped. So now let's get into the another example, just to have a understanding based on the dry run, where I have taken the simple example to explain. This is the array of size 5, and these elements will be firstly divided into two halves. There's 3 elements here, 2 elements here, and these 3 elements then will be divided into again two halves. These 2 elements come here, 1 element come here, and again this process will be continued till the array having only 1 element. Now let's get into the dry run. See, in order to sort this array, the simple function will be called, the merge sort function will be called, that hey function, it will call that function that hey, I have to sort this particular array. So it will give its nums array, it will give the 0th index, it will give the 4th index, that is the low and high. That is for what purpose this low and high are given, in order to calculate the mid index. So now this merge sort function is called, so the control will go to the merge sort function where its implementation is written. Now low is having 0, high is having 4. Now the base case which was written, that is the low equal to high? No, it means the array size is not 1, therefore the condition goes true, and this mid index will be firstly calculated. So mid index came as 2, and now it will call this merge sort function. Merge sort function for the second half, for the first half. Okay, this is the original array which I am having. Now firstly it has to divide it into two halves. So this half, first half and second half. So firstly these two halves has to be sorted, then only we can merge them. So in order to sort them, we will again call a merge sort function. We will make a recursive call for the merge sort function for this first half. This is the first half, 12, 8 and 9. So firstly this has to be sorted, and then this has to be sorted, and when these both are sorted, then we will move back and just merge those two sorted halves in order to get the final sorted array. So this is the recursive call made. This is the recursive call made. Let me just take here. Okay, so now the recursive call is made for the first half. So firstly that has to be sorted, and now what are the indexes for the first half? We have seen here the 0 to 2 index. 0 to 2 index are given as the low and high. Now the control goes to this function, as a merge sort function is called again as a recursive call. So low and high are 2 now. Now again the low and high will be checked. Is this, these are same? No, these are not same. Again the condition goes true. Again the mid index will be calculated for that, and the merge sort will be called again recursively for its first half, for this 0 to 1 index. So again the low and high will be coming here. So this for 0 and 1 it will be called. Now again the function is called again the recursive call. So again the merge sort function will come here, and the low and high will take 0 and 1. Are these equal? No, these are not equal. Therefore the mid index will be calculated again. Again the merge sort function will be called for the first half and for the second half. So for the first half, it again called this 0 and 0. So now now from here itself it will again call this function that is made as a recursive call. So again this function will be coming here, but this time the low and high are given as 0 0. So low and high are equal, therefore it means when low and high are equal, therefore the element in the array is only one, the array size is only one, therefore we will just return from here, because we know that the array which is having only one element, it is sorted in itself, we need not to split again. Okay, so from here itself it will return from here. So and the return whatever the when it will be returned, it will give the control to the next line after this. So the next line which is returned is this merge sort, nums of 1 1. Nums of 1 1 means for this element, nums of 1 1 for 8. So this will give the control to here, and this 1 1 for this merge, this particular recursive call will be made now. So this will again call this merge sort function, and here again low and high are equal, so again it will be returned, because again this is the one element itself. So when it will return, the control will go to the next line of this, and now the merge will be working. Merge will be working like this: 12 is the single element, 8 is a single element, and these are sorted in themselves. So the sorted, these are now became the sorted halves, and now they has to be merged. So this merge function will be working here. Merge function will be working here, and when this merge function perform its work, then it will come to the next line of this, but next line there is nothing to be executed in this particular merge sort function. Then it will give the control back to the another line from where this merge function has been called. Merge function has been called by this merge sort function, so that control will move back to this merge sort function. Okay, and just immediately whatever the next line is there, again that particular merge sort function will be called recursively, and here it will again move to the function. So here merge sort function will be again called, and here low and high are 2 and 2. Again this condition is true, so it will be returned, and it will again move back to the uh, again give control back to the next line after this function. So again the merge will be performed. So this time the merge is performed for this. This is the two parts from 0 and 1 for this merge function, and for this particular 2 index, this is the merge function, merge sort functions. And when these two halves are sorted like 8 and 12, and this becomes 9, then the merging will again happen. Merging will happen, so here the again merge function will do its work, and when its work will be completed, it will just move the control after the next line of this merge function. But because there is no any line to be executed, so again that control will move back to the function which has called this merge function. So this merge function has been called by this merge sort function, so this control will go back to the next line after this. And now till now this particular thing has been achieved. The first half has been sorted, and it means this one from 0 to 2 index, the first half has been sorted. Now the control go to the second half, that is 3 and 11, means for third index and fourth index. And now again the same thing will be done. This merge sort function will be called for it for the 3 and 4 index, and again here the indexes, the low and high, are not same, so therefore it will again find the mid index, and then again check for this merge sort for 3 and 3, and it will just return because both are same. Again for this 4 and 4, low and high, these both are again same, so again it will return from here, and then it will again merge these. What will be merged? These 3 and 11 will be merged. So now the 3 and 11 will be merged, so the merge function will work here, and in the same way this merge function, when it will be completed, it will just return the control back to the next line, and this next line is like the curly brace itself, so therefore the control will move back to the function which has called this merge function. So this merge sort function has called, so the control will go here, and now we have seen here that these two arrays are now the sorted halves. We have sort this first half using this merge sort, and this has been completely this has been completed, and now this has also been completed to sort the second half. And now when both the sorted when both the halves are sorted, so now the merge will again happen here. Now the merge function will again work here, and it will sort obviously they are both the sorted halves, so now it will merge, and based on the logic which I have just explained. So this is the complete dry run of this example in order to have the more understanding that how it works. Now let's get into the implementation part, the code part, where we will be where we have already seen till now that how the merge sort function is working. That firstly it sees for this base condition where the recursion will stop, and then if it is not the case, then it finds the mid index in order to divide the array into two halves, and then it calls the merge sort function for the first half and also for the second half, and when both the sorted halves are achieved, then we merge those both the sorted halves. So this is the simple implementation of this merge sort function. Now how we can write the merge function, let's see that. So now we have came inside the editor, and now let's write the code. So I have already written here that firstly we are calling the merge sort function in order to sort this nums array, giving the indexes 0 and the last index that will be going inside the low and high in order to calculate the mid index. So now this is void and merge sort, and inside this I will be taking this vector int nums, int low, int high, int low, high. And now inside this, firstly we have to calculate the mid index, so that will be calculated using int mid equal to the whatever the low and high we are having, just find that low plus high by 2, and after getting the mid index we will make a recursive call for the first half, in which we will be giving the nums array and the low index and the mid index, that is going to be the first half. And then we will be making another recursive call for the second half, in which the nums array will be given, and now this time it will be starting from mid plus 1 and the high index and the high. Okay, and now when these two sorted halves we get, we will then merge both the sorted halves. That for that I am writing the merge function. Inside the merge function I will have to give the array nums array, and for this merge, because all the elements has to be merged from starting, means for both the halves, for the low to mid and mid plus 1 to high. So for that I need the low, I need the mid index, and I need the high. So this is how it is going to work, and this particular recursive calls will be stopped once it hits the base case. And what is the base case? Base case is simple, that when this low becomes equal to high, then just return from there, means just stop the recursion. Okay, this will be the scenario. Now here we can also take the low greater than high, that I will also explain later. So now let's write the merge function, which is the core part of this algorithm. So merge, and inside this I will have to take the nums array, and in order to merge I will have to take low, I have to take mid, I will have to take high. Now inside this, now let's understand from here, as I have explained here. So in order to merge, what I have to take, firstly I will have to take the temporary array, that is vector int and temp. Okay, I have taken the temporary array in which this merged sorted array will be stored. So this is a temporary I have taken, and now I am having the low, mid and high. So firstly I will have to take this a particular pointer which will be pointing towards the first sorted half, first position, and another pointer which will be pointing towards the second sorted half, second position, for the first position. So that will be, this is low, this is mid, and this is mid plus 1, and this is high. So therefore I will be taking this L, which will be pointing which will be taking this low, and I will be taking this R, which will be pointing towards mid plus 1. Will be taking this mid plus 1. So now these are pointing here. Now I will have to write a particular condition in order to store these, in order to merge these elements in the sorted order. So for this, firstly we will have to put a condition that until this J is not moving out and also this R is not moving out, we will keep taking these elements based on the comparisons. So for that I will be writing the while loop. Inside this I will be taking the condition that until this J is less than equal to the mid and end. Okay, this is the mid index, J is less than equal to mid, and this R is less than equal to high, and end this R is less than equal to high. Till that, do this particular thing, that firstly check that which is the element in this nums array, which is the element out of this L uh, out of this particular positions where L is pointing and where R is pointing. What is the which is the element which is lesser? Because we already know that these are the two sorted halves. So therefore their first elements will always be smaller. So now we have to make the comparisons on those smaller elements so that we can get the sorted order in the final array. So firstly, we will put the condition that if this nums of L is less than equal to the nums of R, then in that case, take the temp array and push back. This is the function which is used to add the elements in the temporary in this vector. So push back that nums of L, and then just increment this L ahead. Else, another condition can be obviously if this L is the L is pointing at any place, then if this is not less than equal to this, obviously this particular R where it is pointing, that will be smaller. So in that case, take that temporary array and push back that nums of R, and then just increment this R. And now there will be the case where I have discussed that at any point, if any of those, this L or R, if any point they are going out of bound, then one which is then one which is pointing at a particular index in any of the sorted half, just take that and one by one put the elements inside the vector. So here we will have to take one another while loop where we will see if any of the condition goes false. If this R less than equal to high goes false, then in that case you will have to take this and put one by one elements inside the vector. Just write the condition L less than equal to mid, and just perform the same process, that take the temporary array and push the elements one by one inside this temporary array, this nums of L, and just move L ahead. And once this L will be going out of bound, so this will also stop. Otherwise, it might happen that this particular condition is false. So in that case, you will take this and put the elements one by one. So for this, you will write the condition R less than equal to high, and take this temporary this vector and push all these elements at nums of R, and again move R ahead. And once this R moves out of bound, again this will be stopped. Now we can see that all these elements are present in this temporary array. Now we have to take these elements inside the nums array. So how we can do that? See, we already know that this nums array has, when it has called the merge function, it has given the low and the high. Low means at the 0th index and high is at the last index. So therefore, in the nums array, whatever the elements will be going, they will be going from low to high. So therefore, we will be writing a loop for int I equal to low, and I less than high, and I plus plus. And inside this, we already know that nums is having this particular as low, and this is as high. So therefore, whatever the elements are coming, they will be coming at this low. Means if we are saying that nums of low, then that element will come here. Then nums of low plus 1 will come here. Nums of low plus 2 will come here, like that. And in the temporary array, we already know that these are the indexes which are represented like 0, 1, 2, 3, 4, 5, 6, like that. So whatever the element will be coming from temp, it will be coming inside the nums of I, okay, inside the nums of low. And when the next element will come, that will be like low plus 1, then low plus 2, then low plus 3, like that. And from the temporary array, now what will be the a kind of formula which we will have to write? So I is the index we are using the low to high in the nums. So I can write I minus low so that it can be mapped. So like when I is low, low minus low will be 0. So from temp of 0, it will go inside the nums of low. Then I is incremented, it becomes low plus 1. So low plus 1 minus low, it will become temp of 1, and that value will be going inside the nums of low plus 1. So that's how the elements are copied from the temporary array inside the nums array. So this is the whole logic inside the merge sort algorithm. And let me just take a simple example, just a simple input in order to run this. 12, 8, 9, 3, 11, 5, 4. 12, 8, 9, 3, 11, 5, 4. This is the 7 size array, and now let's just run this code. Now let's see what is the sorted array. Sorted array will be 3, 4, 5, 8, 9, 11, 12. Okay, so the sorted array is 3, 4, 9, 8, 9, 10, 8, 9, 11, 12. This is the sorted array. So we have seen the merge sort algorithm's implementation, that how the merge sort function is written and what flow it works, and then after, at the time of merging, what is the implementation of the merge function, that how the two sorted halves are merged. So here we have seen the theoretical part, that how it is merged in a structured way, and then we have also seen the implementation of it, that how we can write it in the code, or what is the logic to merge. So this we have seen. Now one important thing I have to explain here is that why we are not taking this less than like we are always taking this as low less than equal to low greater than equal to high. See, if I am taking this low greater than equal to high, that is also the correct way. So when we are writing this low equal to high, that is already sufficient in order to stop the recursion, because whenever the array size becomes 1, or the array size array is having only one element, then in that case that element is already sorted, so therefore we can stop there. And in that case low becomes equal to high, so there then and there we are just returning there, means the recursive calls are not made anymore and the recursion will be stopped. But when we take the means usually like most of us, we write this condition that low is greater than equal to high. So this is just a return in order to have the defensive a kind of defensive programming, so that we can avoid the unnecessary bugs, or if any of the slight differences are made in the function or in the recursive approach, then in that case this greater than we write this condition as low is greater than equal to high. Otherwise the low is equal to high is already sufficient in itself in order to stop the recursion. Okay, so this is just to just return in order to make this particular function more robust. Okay, so this we can also understand from here, means what is the case this low greater than high is telling us. Low greater than high becomes uh, it tells that we are talking about the empty subarray. If we can see this particular example, here I have also written here. Here we can see that when this particular merge sort function recursive call is made for the one single element, in that case the low is becoming equal to high. So therefore it is not even going in the further recursive calls, because it is returning here itself, as it is saying that there is only one element, so I need not to split it again. So it returns from here itself. But there might be the case that in any of the, like in any difference or any changes are done, the slight differences, or in any of the changes are done in the approach, then in that case these two recursive calls are made. One is recursive call is made for 0 0, it means for the first half, and second is made for the second half. Now in first half it is it is correct that it is saying for the like 0 0, it is for the one element itself. But for the second half which we are making, that this mid plus 1 and high, so whenever we are having only one element in the array, in that case the low, mid and high becomes all equal. They all becomes equal. And when we are doing for the second half, that is mid plus 1 to high, so it becomes like this 1 and 0. So if the low, mid and high all are equal, okay, like 0 0 0, then in that case if we are saying that go to the mid plus 1 and then high, so it is just telling us that it is an empty subarray. It is not having any of the like it's a kind of right half is not even existing. So therefore there is a empty subarray, and obviously the empty subarray is not having any of the elements, and so in that way we can say that it is also sorted. So finally a conclusion is this, that whatever the one array element is there or any empty subarray element is there, in that case these two are the base cases where we have to stop. That if any single element is coming in the array, in that case we can stop the recursion, because a single element is already sorted in itself, and empty subarray is also sorted in itself. So here I have just made a try run, in the implementation which I done. In that case I have just found that if I will write this equal to case also, and in order to stop the recursion, it will stop. That is sufficient, and it's that is sufficient in itself. But in just to have a safer side, just to be at the safer side, and also if we have to write a like a robust function, so that any of the bugs or something cannot come, so we can just write that greater than condition also. Okay, otherwise the low grade equal to high, that also works, that stops the recursion, that as well, that is sufficient in itself. But we just write this in order to be at the safer side, and do not get any bugs or something if any slight differences are done. Okay, so for equal to is for the one element, and greater than is for the empty subarray. This is what I have to explain here. Okay, so till now we have understood that why is the merge sort algorithm used, and what is the merge sort algorithm, the core idea behind it. We have then seen the simple example to understand what is the basic behavior of it, and then we have taken this particular example to understand the implementation, that how the recursive calls are made, and how the sorted in order to sort these both the halves, how they are sorted recursively by using the recursive calls, and what is the base case where this recursion will stop. There I have just written a simple implementation for that, that firstly this function will be called when it gets completed, it gets sorted, then this particular function will be called, and when this gets sorted, then the merge function will be working in order to sort these two sorted halves. So this is what the flow of merge sort is, merge sort algorithm is there. And then we have discussed about the merge function, that how it merges the two sorted halves, and later on we have seen the dry run on a simple example, that how these merge sort recursive calls are made, how from where they returns, from where they goes, where the control goes back, all that stuff. And then we have also seen the code for this, how we have to write the code, the merge sort algorithm, a simple recursive approach for this. And then we have also written the merge function in order to merge both the sorted halves. So this is what about the merge sort algorithm. Okay, so now we have seen the merge sort algorithm, and now let's analyze the time complexity of this, whatever the code we have written. So here that merge sort algorithm time complexity is big O of n log n, and this is what makes it important, as it is a more optimized approach than the other sorting algorithms, because all the other algorithms are they are slow at big O of n square time complexity, and that's why big O of n log n time complexity which is given by merge sort algorithm makes it important. So how this n log n time complexity comes? This is the bigger array of size n, let's consider, and now when this array is divided into two halves based on the merge sort logic, so this array gets divided into two halves, and the array size becomes n by 2. Then it is again divided into half, then the array size becomes n by 4. Again it is divided into two halves, and this particular process runs until this division process runs until the array size becomes 1. So this is what happening. The array size was n initially, then it got divided into two halves, array size became n by 2, then it became n by 4, then it became 1. So this division is performed until the array size becomes 1, and this is what something feels like log n. Okay, so whenever any data or any of the, like in the previous videos also, in some of the concepts we have seen that whenever the division takes place, then the logarithmic kind of things come. So here we can see that this is one level, here we can see that this is one level, okay, this is another level, this is another level, and this is another level. So here what we can say, that these are the log n levels, okay, because these elements are n here, like the size of array is n here, and then it became n by 2, that means approximately from here that 4 it became 4, then it became 2, then it became 1. So therefore the number of levels which are formed here, they are coming in the log n form. And at every level, if we see at this level, when we are merging, so we need low, mid plus 1, and high, so all the elements has to be merged. So therefore at the time of merging, the all the n number of elements at this particular level has to be processed. Again when we come at this level, again all the elements has to be processed in order to be merged. Then again at this level, all the elements has to be processed in order to get merged. So at every level, because there are log n levels, and at every level n number of elements has to be processed, so therefore all at all the log n levels n elements has to be processed, so therefore the time complexity goes to n log n. So that is the kind of total work done, because total log n levels are there, and at every level we have to process the n number of elements in order to merge them. So therefore the total work done is n log n, and hence the time complexity goes to big O of n log n. And that's what makes the merge sort algorithm important as the most optimized approach. So that's what the analysis of time complexity is. And if we talk about the space complexity, so this was the time complexity we have talked about. And now if we talk about the space complexity, so yes, the space complexity will be big O of n, because we are using the temporary array, that is the extra array, in order to store the merged sorted result. When the two halves we get, the sorted halves we get, we have to merge them in the sorted order. So in that case we need the temporary array. And if we talk about the stability of this algorithm, as we have also talked about it in the previous sorting algorithm. So for the stability, what is the stability? Means when all the number of like whatever the equal number of elements are present, if their relative order is not changed, then we can say that yes, the algorithm is stable. So in this case also, when we have written this particular code, the condition which we have checked here, the nums of L is less than equal to nums of R. So here we have discussed it. This nums of this L is pointing here, R is pointing here, and we should have written only the condition that L is less than nums. If the L is less than nums, you just take this L and then just move this L ahead. But what if, let's say, here is 3, here is also 3. Now if we have checked only this condition that L is less than R, means nums of L is less than nums of R only, without the equal case, then in that case the condition will go false, and therefore this 3 will be coming first. This 3 will be coming first, and this R will be moved ahead. And again, when this condition will be checked, so this 3 will be coming now lesser than this 5. So then this 3 will be coming at this place. And now you can see here, whatever the relative order of the elements was there initially. Okay, like this particular, let's say if the both of the threes will be there, so this 3 will be coming first and this 3 will be coming next. So therefore the equal number of elements, the relative order is changed. So therefore we have to put the condition this also equal to, and this is the must condition in order to maintain the stability. And this is the condition which tells that yes, the merge sort is stable. So if we put the equal, then this 3 less than equal to 3, yes, the condition goes true. So therefore this 3 will be coming here, and then this 3 will be coming here. Therefore the equal number of where the equal elements, their relative order should not be changed, and therefore we are putting this equal to symbol, so that if any of the equal elements will be coming, then the first element from the first sorted array will be coming here, then the other element will be coming. So that's how the stability is maintained, and yes, we can say that the merge sort algorithm is stable because of this condition which we have written here, nums of L is less than equal to nums of R, so that the equal elements are, their relative order is not changed. So this is all about the merge sort algorithm I have explained, and yes, whatever the code will be there, I will be putting inside my GitHub repository, and that link will be in the description. Thank you.